Hey guys, welcome to the live stream where we're living right now. We're still live preparing. Let's see, this goes to minus 29 and a bit there. Good evening. Oh, sorry. How is everyone doing tonight? And can you even see or hear me? Because I changed a lot of the streaming setup. We're now running through AV1. It's okay, it's still choppy, I don't know why. With, you know, the new RTX 5070 Ti. I saw one come by for MSRP, and I was like, let's get it. So I was complaining, I think last week or the week before that I couldn't get a new video card. Well, for MSRP, I think it's a good deal, because the RTX 5070 Ti has dual NVENC engines and improved AV1 encoding for better quality, etc. So that is perfect for a streaming machine just like this machine right here. And I was able to put the memory from my desktop in there, so now it has plenty of memory, and I updated the BIOS and updated all kinds of stuff, which I generally don't touch because, well, I need to record and stream with this thing. So yeah, we're now fully in an AV1 workflow. That's going to save me a bunch of storage, because sometimes it was taking up a lot of storage. So yeah, let's see who's all here. Oh, I didn't even pop out the chat yet or fix it, or I just immediately started rambling. I didn't even check if you can hear me. Can you guys hear and see me? YouTube chat. There. Here we go. T-shirt weather in the Netherlands. Yes, for sure. It was nice weather today. So Draadstaal was here first, and he immediately hit the like button. I appreciate that. Oh, and little Papa John hit it for the second time. Nice. It's going to be good tonight. Maybe some magic smoke. Yeah, we'll see. We've got 3 Chinese power supplies. We're going to load until they, well, explode. Load and... That's a good name for a series. Load until it explodes. Anyway, or until protection kicks in. So... Oh, Draadstaal looked at the script. No smoke. Oh. Bright burning lights, power outages, melting plastic, and a small chance of nuclear explosion. Who knows? Who knows? Some Coke Zero. Actually, yeah, no. If it's today we've got the raspberry, which I need to be careful with because they don't sell it anymore. They've replaced it with, I don't know about this one. The camera doesn't know either. Tutti Frutti. It's funky. It's funky, but yeah. Yeah, the audio ducking indeed still works when even the microphone isn't active. I haven't been able to solve that part. So, sound is clear. Yeah, but are you getting upgraded visuals? I don't know. Tutti Frutti is okay. Yeah, it's yeah. So on your stream, if you're on a computer, right-click your video or my video, right click on me, and then hit stats for nerds. And I'd like to know the codec the video is coming in with. It's just interesting. Because now, instead of H.265, because I was already using HEVC, I'm now using AV1. The magic of AV1. And sometimes it's still choppy, sometimes it's not. I don't know why that is, but I don't believe the output is choppy. Because before, my rendering engine, my video codec engine, was like at 85%, so it was ready to burst. Right now, we're at a comfortable 36 to 40%. Nice. Well, having improved quality, actually. So, double nice. I haven't yet decided how we're going to test these things. We'll see. And for people who are here more often, is there more delay, or is the delay about the same, or, you know, any differences you see? I'm using the same bitrate. I'm using 32 megabits to stream to YouTube in 4K 60. No, wait, in 1440p 60, because YouTube doesn't support 4K streaming, or at least not with any normal latency that is, no issues over here. Cool, no delay, noise. Yeah, so YouTube with a small delay doesn't support 4K, but it does 1440p 60, which we're doing. So yeah. Yeah, but check the right click on the video and then stats for nerds. I'm watching at 1440p. Yeah. But stats for nerds, and then what does it say for the codec? Is anyone getting this in AV1, or is the live streaming still VP9? Seems no delay here. Good. Oh, right. I still need an AC cable. Do I have one here? Maybe. Yes. Good. VP9, MP4A. Okay. Can't read stats for nerds because of the chat text. What? VP9. Okay. So YouTube is downsampling it to VP9. Okay, we're re-encoding it basically. Interesting. Oh wow, you typed it all fully. Okay. Oh, in the US. Interesting. Thanks, CleanSC. Okay, so YouTube isn't streaming AV1 to clients yet then. In your client preferences for YouTube, you can actually enable or disable VP1 if you want, or AV1 if you want to have it or not. But I don't know if that affects streams. Interesting. I like all that technical blah. I'm like giddy that I can move my workflow from HEVC to AV1. I mean, it's just stupid. It doesn't mean anything. But yeah. Oh, that's okay, Coyote. Thanks. Now would be a good time for an ad. Well, now would be a good time to click the close button. Okay, let's prepare this a little bit. Because after the power supply testing, I want to do another test with the power supply and actually hooking it up like I'm going to be using it. So, yeah. So let's see if the overhead still works. Yes, it does. Okay, we have one of these connection blocks, and I have an AC cord. So we're going to hook this up real quick. Namaste. Hello, Arun. Welcome. So this goes to here. This goes to here. And this goes to here. There. And now we can easily, this is secure, so that's good. Now we can easily hook up the power supplies individually. Oh, there's still cat hair on my desk. I'm not sure you can see that. That's okay. Now, we need to figure out how we're going to hook these up, because this is an example. This is the new guy. It doesn't actually say it on there, but we'll test this one first. It's quite hefty. It's probably fully potted. It is because it's a 300 watt. I believe they have 120 to 200 watt versions that are full voltage range, but this is 175 to 277. So you need to have 230 volt AC. It doesn't work on 110. So that's something to remember. The lower rated versions do work on 110. I don't know why it says 277 volt for North America only, but okay. So it's supposed to do 12.5 amps at 24.5 volt DC out. Okay. Well, we'll see about that. What is this? What? I can't even read that in real life. Can we read it like that? Oh, there. Use within specified rating, wired accurately after verifying wiring diagram. Ground the earth terminal to prevent electrocution during the installation with the space of 50mm or more in between. Certainly install after reading the installation manual on. Okay, sure. That's well, okay, that's decent English enough. You know. VP9. Okay. Thank you, Gary. Hey there, Greg. So the AC side is easy. We're just going to hook that up to a Wago and then we're done like that. But then the DC side, we got 2 wires, which I want to go to a tester each. Oh, these are 2 times 1mm square. Okay, well, that's okay. So they're going to do 5-6 amps each. Yeah, that's fine. Plenty fine. Okay, but then how do I go to the tester? Let's undo the wires in the tester first, because we're not going to be able to use these. And let's okay, move these away. Actually, I hope 2 testers is going to be enough. These testers are, I think, about 150 watt each. So, in theory, they can handle 300 watts, but in practice, I don't know. We're going to see. We can hook up a 3rd one, but then we have to be creative with the wiring. Okay. So we need some AC or some 12 volt for the testers. Now these are waterproof power supplies. I always find it a bit dodgy when you use a waterproof power supply, because that would imply everything else would need to be waterproof too, I guess. And I don't make any waterproof controllers, so I don't know about that. But I guess if you wanted to keep the power supply out of the box that you have the controller in, that could be an option. That could be an option. Now, we can wire this up by wiring this directly in here, but we need a 4-wire measurement. So we have 2, let's see, 2 positive terminals. These 2 are positive, and 2 negative terminals, and all of them need to be connected. Now, okay, so the load needs to go to the middle terminals, and then the sensing is done on the outer terminals. We can use a bridge wire for that, that's fine. Or I'm thinking we could maybe use a fork. We'll make a little wire. Let's see, where's my wires? Here's my wires. Let's just make some wires. So we need some red, some black. These are solid wires, so they're easy to use for all kinds of stuff. Now we're going to assume 2 testers to start with. So we don't need a lot. Let's make them this long. Yeah, okay. Something like that. Can't find the end. Oh, here it is. Nope. There. Something like that. Okay. Wire strippers. Let's strip them a fair amount. Because officially this thing does 4 wire measurements. So you're supposed to run a wire back to the source, but in this case it doesn't really matter. We actually want to do a measurement at the end of the wire. Okay. Now let's see how we hook this up. We can do the AC side last, whatever. Okay, so they need to go into the middle terminals like that. At some point I'm going to fix that wobbling mount. And the middle terminals like that, but then we need to add these little wires which go into the terminals besides them. So let's screw that down first. There, that should be okay. And then screw this down. Let's see if this, yeah, see, that's what I was afraid of. Now, this wire isn't really, it's not the same diameter. So, so even if we screw down the big wire, it's not going to clamp the small wire, right? So I'm going to have to kind of overlay it on there and then screw it down. Maybe I should twist around it. We can try that too. Yeah. Okay. That's okay. There's not going to be a lot of current there, so a loose connection is fine. So I'm going to do the same thing here. I'm going to kind of overlay it there so that when it squishes down, it basically clamps it down. See? Yeah, that's fine. And then bend it like that. Your wife cannot believe how many people are watching this? What do you mean? What does your wife mean by that? But welcome, Jim Jenkins. Love your channel and content. Thank you very much. Why can't your wife believe people are watching me? What is this? Now we need to figure out how we're going to position this. I guess we'll have to do it like this. In the end, only the power supply is most interesting. Damn it. Your wife can't see why people are watching some random guy from the Netherlands fiddle with wires on a live stream? It's because my wife is not at home. I can watch this in peace. Aww. Yeah, let's try it like that. That should do it. Yep. Everybody wants to see magic smoke. I get that. I want to see magic smoke too, except when I blow up stuff I don't want to blow up. This I'm not too attached to, so we're gonna load them until they overload. I told her this was the best Netherlands LED channel in the world. well, I would say it's the best LED channel in the world, even without the Netherlands part. But sure. I guess it's my Dutch charm and my heavy accent. Well, I could try to talk more with a Dutch English accent, because I hear lots of politicians on the TV do that. But I myself think that very crappy. So I try not to have such a heavy accent, right? Okay, I'll stop that. Sorry. Oh man, it's even hard for me to do an impression like that. Okay. Okay. Please don't do this. Luckily, my wife leaves me alone for nerdy stuff. It's the best LED channel in the universe. You should speak French. That's more hilarious. Mon français est très terrible. C'est ne pas une option. I don't know what option is. Okay, my French is not great. Ik spreche besser Deutsch. Ist Andy in the house? Mein Deutsch ist auch nicht sehr gut, aber ist sicher besser than mijn Französisch. Französisch? I don't know. Beetje Haags praten kan ook wel, toch? I don't know how we're gonna position the testers here. There's one here. We don't need this one. Okay, let me move the cardboard box off of the desk there. Let's hook up the AC side. That should be pretty straightforward. There. Yep. Impeccable. Okay. Let's bend this out of the way. Okay. Yeah, no, I try not to have a too heavy English accent. Or Dutch accent, then, I guess. I don't know. My wife is looking for... what? Nice. Just for making us suffer through the part of the stream, you should make smoke. Well, I don't know, Philip. We'll see what happens. Okay, let's do this like that. I don't know. Let's try this. Let's first turn on the testers. Oh, I made like already a fire in the background so that, you know, it's nice and toasty here. The testers are on. Where's my safety? Do I have safety glasses? Yes. Safety glasses courtesy of Draadstaal. The bottom is smoke. Yeah, the Quinn smoke. Right? We need to build one. Okay. So, we have our wires hooked up. I think I did this correctly. I'm not 100% sure, but we'll soon see. Somehow there's already a volt here. 0.00. I don't know. Are we ready to hit the power? If it explodes and the stream is gone, you know what happened. Beam. Okay, we're seeing 23.94 unloaded. That's pretty good. With that small room, yeah. This room is... this room isn't big. That's why we're building the new place at some point. But, like, I'm touching the wall here. Okay? And I'm basically touching the wall here. That's it. There's no more room. The other wall is here. So this is the other wall. And the camera is, like, in the windowsill of the wall over there. So, I can touch all walls without, like, even having to move. It's convenient because everything is close, but I'm running out of space. It's not convenient anymore. But yeah. Okay, so we have power. It's been stable. How many amps can we do? 12.5. Let's start with no. Let's start with 3 amps. Oh wait, let's get the thermal camera out. Oh, I didn't check if they had a firmware update with which I could maybe link it. Well, we'll have to see. Okay, I have to remove the macro lens. Let's go for 6 amps. There. So this is 71 watts and this is also 71 watts. So we're doing 140 watts of the 300 watt power supply. Yeah. Let's see if we can actually measure this thing. Let's try and measure something else. Yeah, okay. Currently it's stone cold. I'm sorry, I'm not able to stream this camera yet. I want to be able to do so in the future. You can see the tester though. The tester is getting warm. Yeah, it's 300 watts in total. So for the 140 watts, we're drawing 160 watts. That's pretty good. That's okay. So let's go to 5 and 5. We're getting a little bit of voltage drop, but that's just because of the cabling. But the cable is actually an adequate size, I'd say. Yeah, these tiny wires are not getting warm, so I hooked them up the right way this time. So now we're doing 120 and 120, so that's 240 watts, and we're doing 268 from the wall. Wow, that's pretty good. 268 divided by 240. No, 240 divided by 268. Oh, that's 89% efficient. That's pretty good. Well, as long as nothing happens, it's pretty boring. Let's see if it's heating up. Oh, yeah. We can see this little spot here is getting warm. It's 33 degrees, but the other than that, I don't see. This is just heat reflection from over here. Can we see on the bottom side? I can see on the bottom side. Hold on. No, nothing heating up. It's stone cold. Okay, so then let's let's go for it. 12 amps. I mean, most Chinese power supplies we've tested before were like 25% of their rating. Well, there's a sticker here, for instance, Philip. So, and it's not shiny metal. It's kind of matted metal, so it should be okay-ish. Yeah, this power supply is fanless and fully encased, so IP68. So right now we're doing 143 plus 143. That's 286, and we're drawing 322. Let's do quick maths. 286 divided by 322. Okay, now we're at 88% efficient, 88.8. So still about 89. That's pretty efficient. Now let's see if something's getting hot, because we're basically near the 300 watts now. 143 and 143, 286. That's about 300. Yeah, it's starting to warm up a little bit. I can at least see it on the thermal camera now, like that. Let me zoom, move away a little bit. But I mean, the warmest part is like 35 degrees. This here on the side doesn't count because that's where some air from the tester is going. And I mean, the high efficiency kind of makes sense, because if you're building a passive power supply that has to radiate all its heat, well, the higher efficiency, the better. That's why the UHP series from Meanwell is also that efficient. Well, it might be warmer on the inside, but because it's potted, it'll take a while to go to the outside. Yeah, bottom is still cool. Yeah. So let's see how much it'll do. We're now at 166 here. Oh, okay. Oh, no, 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 no. Okay. The voltage went down when I did that. So let's go back here. Okay. So 6 amps here and 7 amps here. That is 13 amps, which indeed exceeds the 12.5 amp rating. So, okay, sure. Voltage goes down when amperage goes too high. That's fine. 166 plus 143. How much is that? 166, 143. That is 309 watts, and we're drawing 350 from the wall. That is 88.2% efficient. That is pretty good. Well, let's leave it running for a little bit. Of course, it's getting a little bit of airflow right now. Well, it's actually IP68. I think. Does it say on here? Oh, no, sorry. IP67. You're right. Yeah, exactly. All the wires come pre-attached. Let's measure again a little bit. It's 39, 38.6. Maybe over here. No. Oh, 40 degrees. Yeah, let's leave it running at 310 watts. That's 10 watts overrated. I'm starting to smell something though. Not sure it's the power supply or my testers, because my tester is also burning away 167 watts, so that's a lot. Well, I think it's just my tester getting warm. Yeah, it's nearing 40 degrees now. But, I mean, 40 degrees is fine. It's still, you know, easy to touch. That's no problem. Backside also isn't very warm. Wow. Yeah, and this one wasn't expensive either. Now again, this is only for EU markets. Because it's a 230 volt supply only, so not 110. The lower models do go down to 110. Let me open the link myself. This is the new guy. So the first one in the list. Yeah, and it's 33 bucks. And that's, you know, that's not a cheap power supply, but it's also not expensive if it, you know. Yeah, exactly, Clean SC. If you've been to the previous tests, this is a 5 kilowatt power supply, and then it does 100 watts. Yeah, but voltage is also perfectly stable. I mean, that's fine. And we're right at the limit, so we're right at the rated power supply rating. So, oh, they even have a 400 watt version, but it's actually bigger. Oh wait, these are, oh okay, yeah. So the 200 watt version is 100 volt to 265, so that can be used in the US still. But the 300 and the 400 watt are 180 to 265, so that is EU only. Yeah, and it's 33 bucks. I don't know what I paid for it, but something like that. Let's see, the power factor. Oh, the power factor is 0.596. That's okay. But it's not active PFC like the Meanwhile UHP are, for instance. That's okay. That's a feature that adds a lot of money, so. Half the price of a Meanwhile UHP, yeah. Now, I'm not measuring, you know, ripple, voltage ripple, and things like that. Of course, for the applications we do with the LEDs, you know, you could say that's less important anyway. It just needs to be fairly stable. It doesn't need to be medical grade or something like that. So, yeah. Okay, it's heating up. It's heating up for sure. So let's see. I'm trying to show you too. 43.4. Okay. Can't really detect any hotspot. So this says 47, but I don't trust that because that's where the heat from this guy is also coming from. Yeah. I mean, for this channel, we're mainly looking at LED projects, I'd say. And for LED projects, you don't need to have the most perfect stable voltage in that sense. As like, wait. It couldn't sustain it. So let's back off a little bit. Okay. Now we were over the limit. We were drawing 310 watts instead of 300. So now we're at 143, so that's 286 again. Okay, but that's actually good. So if it starts overheating, it will lower the voltage. That's fine. That's a good method to do that. Late to the party. Hey, Germs. No worries, we're testing Aliexpress power supplies and my new streaming setup. Well, it's the same setup, just a new video card and updated PC. But so far, it's all working perfectly well. Okay, the bottom side is now starting to become harder to touch. But yeah, we had a bit of voltage sag, but we were overdrawing it. So now we're close to 300 watts. On the product listing, they state, like, don't draw more than 80% for a long period. You know, like most power supplies say. So we are maxing it out. Have to be fair, right? Yeah, so it's now around 45. Let me check the bottom if we can measure that. Okay, yeah, okay, so now the sides and the bottom are 51. So that's why it's becoming uncomfortable to touch. Hey, Timothy, welcome then. It's the same time as always. Yeah, but it is getting pretty warm now. We've been testing for about 12 minutes. And I mean, if we're being realistic for LEDs, how often? Well, okay, it depends. If you're doing digital LEDs, you don't often draw maximum power for a long period of time. If you're doing analog LEDs, however, you might. So yeah, and even, I mean, for 33 bucks, it's not cheap, but it's also not expensive. So even if you're doing an indoor project, you could consider them. I think, you know, an open frame power supply will be able to get rid of its heat better. So if you're going to do near 300 watts the whole time, maybe don't get a power supply like this. But if your max is 300 watts and generally you're much lower, like mostly with digital LEDs, for instance, I think this could be a good choice. Now that we backed off on the amps a little bit, voltage seems quite stable. Oh, you're looking at doing some strips on your balcony. This might be good. Yeah. So one of the applications I have for this is I want to do a strip in our garden room, as I call it. So that's half inside, half outside. And I was like, nah. I sometimes see these come by on the affiliate websites. So it's like, okay, let's buy one and just test it and see how good it is. But I'd say this is pretty good. Oh wow, they state efficiency 80%, but we're getting more than that. So let's see, we're getting 143 and 143, so that's 286 divided by 323, 88.5%. Yeah. Yeah, later as we'll build my intended setup and we'll see if it actually makes noise. That's an interesting proposition. Okay, so we've almost been running 15 minutes at max load. So let's take a look at the temperature again. 51.7. Maybe I can show you like this. Oh, that's the tester. Yeah, 48.6. Yeah, okay, can't show you that. Yeah, seems the max load is about 48. Let me try and get a good picture. Yeah. To run your traffic light. What? Okay, yeah, the bottom is warm, but that's because it's basically being insulated on the desk on a, on a desk mat. So let's see what the bottom became. $52. Yeah, the bottom is uncomfortable. It's uncomfortable to hold now. So the bottom is about 52.9, 53. Still, that's not bad. And I mean, if you're, serious about this and want to use it near maximum, you could also mount it to a metal plate, like the Meanwell UHP also advise. So then the heat has more area to spread it out. Well, Greggy, they might deliver like 1/3 of the rated output. All the previous supplies we've tested was like hot garbage. Okay, we've exceeded the 15-minute mark. I don't want to make this too boring. I would give this a definite pass. Oh, you have the same series power supply, 12 volt, 300 watt. Survived 2 years of an outdoor Christmas tree. And then it died, or you took it down, or it's still there? What's going on, little Papa John? Okay, I'm going to stop the test. How would you compare it against UHP? Well, the UHP are, for instance, 500 watt or 250, I believe. I'm pretty sure the voltage regulation on the UHP will be much tighter. The UHP also has an active PFC, so it's going to be much more efficient in regards to its power factor. Oh, you took it down every year, so it's still alive. Okay, cool. So, but yeah, for generic LED projects, this might just be fine, right? My testers are still cooling down. Oh, there they go. Okay. So idle wattage is 1.87. Well, that's okay. That's fine. Cool. Yeah, let's turn it off. That's pretty good. I had a feeling it would be okay. So let's remove this one and test the next one. As I said, I didn't measure ripple or anything like that. Okay, AC side is off. Could still, spark. No, this was a 24 volt one. Okay, let's not touch the wires. Yeah, it is definitely hot. I'm just going to put it on the ground. Oh, there we go. So the next one we have is from a different brand. Oh, wrong one. And this brand kind of mimics Meanwell a little bit. Always find it funny. It's an LPV 250-24 from, what's the company called again? Miwei, I don't remember. But yeah, 250-24. This kind of looks like a Meanwell logo sometimes on Aliexpress. Find that funny, but let's give them a fair shot. So same type of deal. We've got the AC wire pre-attached and 2 output wires. That's good with the amount of current. This one says it'll do 10.4 amps at 24 volts. It's also IP67, so fully, you know, encased. Oh, no clue what that says. It probably says, "Don't put on desk with insulating mat. Will overheat." Oh wait, we could. Can we Google? Google, yeah, translate that. Let's try it. Let's try it. Translate. Camera. Open camera. Okay. There. Wait. Okay. Switching power supply inspection certificate. According to the inspection results, the product meets standard requirements and are allowed to leave the factory. That's good. Warning: non-professionals are not allowed to disassemble the machine to avoid electric shock. Okay. Oh, I'm glad we know that now. This is the quality control sticker. Okay. Well, my rule with Chinese products is if there's a brand on there, it's likely going to be fine. But I didn't see it on the other guy. No, the other guy didn't have a brand. Can you connect if the earth wire check? Oh yeah, we can check that. We need to enable this guy. Let's get the other one too. That's a good check, Philip. Thanks. Oh, we don't test any 12 volt today. We're testing two 24s and then a 48. And then later we're going to do something else with the 48. So let's see. Continuity. Okay, I can measure the shell. I can't measure this shell. No, I don't know if you can hear the beep, but... So is this coded, or can I measure the screws? Okay, I can measure the screws. Okay, can I measure the screws here? No, probably not. Oh, okay. So, okay. Let's see. Neutral? No. Live? No. Earth? No. Screw? Oh, okay. So, the shell isn't connected to earth, but the screws are. Yeah. Interesting. Let's try the other one. I mean, if the screws are, the shell is likely... I mean, the screws are in the shell. Wait, how does that work? So I can do this. You can hear the beep. Actually, let's enable the overlay and see if now performance doesn't tank. Hold on. Because that's actually one of the reasons I wanted an upgrade. If I enabled the performance counters, yeah, my CPU and everything was going to be a bit, how you doing? Where did it go? Hold on. It's moved out of the screen somehow, so I need to fix this. Okay, I'm going to try and yeah, it's okay. Transform, where are you? Reset. Ah, okay. Okay, so I need to fix this now. Hold on. How's that? That should be pretty clear, right? So let's see how my CPU is doing. CPU's fine. The video is a bit busier, but that's also still fine. Good. Yeah, so I'm confused about this one, right? So this is working. Oh, it's not working over here? Okay, it is, okay. And then the screw works. No, the screw doesn't work. So screw to housing doesn't work, but screw to screw does work. So the housing somehow isn't connected to the screws? How does that work? No, it is. There's some scratches here. I don't understand. Take it apart. I'd rather not. But we can try later. Magic. Okay, let's try and measure resist. Oh god, I can't. Okay, let's try and measure resistance. Oh wow, there's like mega ohms of resistance. So how much resistance is there between the two screws? Yeah, so this is pretty well connected together. Yeah, so this is basically connected together, but these 2 points... Oh, okay. Yeah, no, two... Yeah. And these? No, well, there's some scratches here. And I agree with what you say, except that we can measure continuity on the shell itself. Right? So if I do this, I have continuity on this point, on these points. So then if I do this, I don't. So, I mean... Yeah, no. So I have continuity here. I don't need to scratch anything. And I have continuity here. I think the conclusion is this part of the shell isn't connected to the screws. And if we take the earth line, it's not connected to here, but it is connected to the screws. Yeah, and over here I think it's a coating problem. Let's check on the back, because there are rubbers here, so... Oh, okay. On the back we have two mounting, they're probably standoffs on the inside, which are uncoated, and those are definitely connected. Right? Okay. So I think everything is connected, because this is right here. There's no insulation between there. So it might actually still be the coating. But there's no coating over here, and I also can't get a connection. So this main shell over here on the top might actually be insulated somehow. I don't know. There's a screw here on the side. Yeah, that's also... I think it is earth, but that the insulation is somehow messing with it. Okay. So this guy, let's measure the screws. So the screws are definitely connected. This point is. Wow, that's funny. So this is anodized, I think. And if you hit a point where they remove the anodization to make the letters, so over here, no contact, right? But over here, contact. So this shell is earthed. If you'd make a scratch on this, it would register. But if we do this, yeah, okay. So, you know, that's properly earthed. That's fine. That's good. Now, are we getting any frame drops or lags or anything like that because I now have the overlay active? I don't think so. New reading for blind people, exactly. Cool, I can now have the overlay active and we're still in 60 FPS. Yeah? Noise. Okay, let's hook this one up too. Now, these have non-standard wires. That's okay. I think we can assume that this is ground. Can we assume that? I don't think we can assume that, can we? Okay, we'll hook up AC first. So, this should be ground. This should be live. And this should be neutral. Now, I'm noticing something bad on the pre-made cable there. The earth wire has an extra cut in it. Now, if any wire, earth is the least of the problems. But they likely, they pre-cut it and then they did it again or something. I don't know. Okay, well, it's not a big problem, but it's not perfect either. Okay, let's turn it on. See if it explodes. No explosion. Oh, well, the idle wattage is now 0.5. That's pretty good. Let's measure some voltage and make sure the wires are what we think they are. Probes. I think this is ground. And this is live. Yes. Okay. 24.01. Okay. So let's turn it off again. Yeah, it was supposed to be February, and then it was supposed to be right now. And right at the last moment, we got word from the factory that they again had a delay. So I already had the video finished for this week. And, well, then I had to postpone it. This is not connected. This is connected. Okay. So, I wanted it to be this week. It didn't become this week. So we should receive them early next week now. And we will immediately ship them out to Dr. Z's and Jerem's for local in Canada. And then I hope to be able to release the video that they're available again at the end of next week. Oh, damn it. That is the best estimate I can give you right now, or Road and Turf. Need them for above my cabinets in the kitchen. Yeah, they should do great for that. Plenty of light. Let's clamp this down real good. Okay. Yes. Yes, got it. Okay, other one. Maybe we can do it like this time. I think so. Oh, for those wondering about an update about the PC, after the stream last week, I pulled apart the loop and I started noticing there was all kinds of residue in there. And I quickly tried to clean it, and I even had it soak in water and dish soap for like over 2 days after that. And well, basically I can't clean it unless I go in there with a brush and really go at it. So I quickly decided to abandon that plan and went back to an all-in-one. I got a Be Quiet Silent Loop 360, and that's been performing great. It keeps the Ryzen 9 9950X3D at max 75 degrees, and it'll vary its speed to keep it at max 75 degrees. And that's perfect. I get really good benchmarks and the system feels great. So the memory, the motherboard, and the CPU combination is really excellent. And I've been very happy with it this week. Lots of upgrades. Because I also managed to find a video card for this guy. Still want a 5090 for the video editing because I run out of VRAM a lot during video editing. But I'm not going to buy it much above MSRP, so it'll come when it comes. Okay. So this guy we can have like this. Let's turn on the power. Okay. Let's go to 3 amps. Okay, we're getting basically 24 volts spot on, so that's good. And any magic smoke yet? No. Glare, yeah, I know there's glare on this one, but it's not that important as long as you can read this one, I think, because the voltage display will be the same. So let's give it 3 amps. I didn't check what kind of diameter these cables are, but they feel about the same diameter, so that's good. Now this one will only do 10.4. I can't see like that. Well, it's okay. So 3 amps, no problem. 6 amps, no problem. So let's see, we're at 71 plus 71, or 72 I should say, and we're drawing 154. 93.5% efficient, wow. So let's see what this one costed. $24 volt, 300 watts. Oh, this one is also 33 bucks. But again, it's 230 volt only, so make sure you watch out for that. Okay, let's ramp it up. So now we're at 8 amps of the 10 we can do. All fine. Let's go to max. Okay, yeah, the voltage is sagging a little bit, but that's likely just because of the cable, not so much the regulation inside. It's still stone cold, so let's do a wattage calculation real quick. We're at 120 plus 120. That is 240 watts. It's rated for 250, so that's pretty close. And we're doing 259 watts from the socket. 92.6% efficient. Wow. And let's see, PFC wise, oh, we're at 0.591, so it's not an active PFC. That's okay. I'm gonna drink some raspberry taste while we're waiting. And after this, we're gonna test a 48 volt version of this guy, and then we're actually gonna hook up the 48 volt to an AN Penta Mini with a 48 volt LED strip. See how that goes. Yeah, let's see how warm it's getting. Yeah, I'm not sure I can position the testers. No. I'd rather have this one straight. Okay, so let me take a quick look myself. Doesn't show up on my tester. Oh, okay. I'm measuring 39.5 as a hotspot somewhere. And that's it. Okay, so let me maybe do it like that. There. Now we also don't have glare. And I can show you the thermal image. Yeah, we got a 39. Let's see if I can focus on here. Yes. Anyway, there's a hotspot over there, which is 39.6. Okay, so this one says discharge time 40 and this one 140. So let's wait until 30, then it had a 10-minute test or something like that. And then we'll know. Yeah. Interesting. While that's running, I'm going to get some other stuff we'll need for after this. So, hold on. Ah. Oh no. My headset went to the ground. So we're going to need this. And we're going to need an AM Penta Mini. And then later, with a 48 volt supply, we'll hook it up. Because this is actually a test strip I had commissioned a while back. But it's a 48 volt 2700K in IP67 new. And that's important. This is a 5 meter strip, so I got two. They're about 10 watts a meter. So this is about 100 watt in total. But yeah. And we're going to hook that up to the 48 volt supply to see how it does when you use it for PWM. Right? How about simulating flashing LEDs? Let's see how warm it's getting. 36.6. Okay, that hotspot from before is now 38.8. Yeah, it's barely warm. Wow. I barely feel anything. And again, the output voltage is stable. No problems there. Yeah. Now, don't put your fingers into the fans, people. What happens if you overload it? Oh, that's a good point. Let's see. 6 amps. Oh, well, yeah, no. Voltage is going down. We're at 22 volts now, 21, 22. And if we go down again, yeah, okay. Yeah, so if we massively overload it, it basically stops providing power. Goes into hiccup mode. That's good. Let's see if it recovers. It recovered. No problem. Yeah, okay. Yeah, that's excellent. Excellent behavior. Good. Safety gloves. No, it's okay. Still have 5 minutes to go. Do people have questions? Ah, stupid safety glasses on my nose. Yeah. Better. A short circuit test. Well, sure, we can do that. But it'll likely respond in the same way, as in it'll go into hiccup mode. Do you know the lotto numbers? Yes. 429274462. That should do it. Cool, Ditto. Glad you got it running. Are you sure you can get some Queen LED gear later, or for a different project? That's fine. So let's check the temperature again. 40.8. On this one, you can see a pretty good separation between the side. So here is the hot spot on the side, and the top. The top isn't getting warm at all, but the side is slightly. Yeah, and the bottom. Yeah, no, nothing's really happening. Yeah. Oh wow, this one is really good. Probably because it's so much more efficient, right? Wow, how efficient is it? Wait a minute. So we're drawing 240 watts, and we're the wall is doing 259. 92.6% efficient. That's likely why there's almost no heat to speak of. Nice, Timothy. Yeah, we're gonna play with the AN Penta Mini in a minute here. Yeah, the wall does 259. Yeah. 259.1. Well, we're drawing, without losses, 240 watts on this side. So it's only drawing 19 watts more than it's providing. That's really efficient. Yeah, ditto. Glad to hear that. Yeah, it's been working out pretty good. His sales are slowly starting to ramp up, and I believe people are very happy with him. So. Bart, I agree. I think they're both good PSUs. The other one feels more like a solid brick than this one does, but this one is definitely more efficient. So yeah. There is no EU warehouse yet, but it is my main focus for this year to get something done there, because, yeah, shipping prices are just out of control. So, yeah. Okay, we've reached the 1:30 and the 30-minute mark. When? Yeah, I can't say yet. That's going to take a few months, though, at least. TCI PSUs? I don't know what TCI PSUs are. Okay, let's shut it off. Oh yeah. It idles at 0.5 watts. That's also quite good. Oh, I can finally remove these stupid glasses. They hurt. You can see the voltage seeping away slowly. Sorry, no, I have no idea, Don. Okay. Well, that worked perfectly. I don't think we need to do a short circuit test. If it goes into hiccup mode when being overdrawn, it'll go into hiccup mode when being overdrawn. So, yeah. That's fine. So, for these, for this one, it has CE and self. I don't know about that. Okay. So this one has CE, but no CSA or TUV, I think. Yeah. Or did you mean for my products, Gary? Okay. That can go there. These can go. Because we're now going to do something different. May not recover correctly on short circuit. Yeah. I have a pretty good impression of these, and I think they will do fine. But yeah, that you never know, Rich. But I also rely on testing, and we just gave this power supply 100% load basically for 15 minutes, or at least 10 minutes, and it did that pretty well. So yeah, I think that is okay. Okay, let's get the last power supply. And that is basically the same as the previous power supply, but now in a 48 volt version. Because, okay, AC is off. Let's hook that up. We're going to hook it up to an AN Penta Mini and hook up some 48 volt LED strip and test it that way. And that is actually the way I want to use it here at home. Okay, so we have the 48 volt power supply. Now it's a little bit Quindor checked, yeah, a little bit different, because with 48 volts it'll only do 5.2 amps, because the higher the voltage, the lower the amps for the same amount of wattage, which is perfect because now we only have one wire to deal with instead of two. Which again lines up great with an AN Penta Mini. First we're gonna flash this AN Penta Mini to make sure there's some kind of WLED on there we can connect to, because I do not know what is currently on there. Okay. I'm not going to show this part. It's just going to install and then install aquiniLED.info and installing it. Of course, this comes from my stock, and you never know, see, what is in there and if it's working. Oh, wait, I need to enable the serial port. Yep. Okay, it is erasing. Good. No, I think this has an actual CE certification. I mean, it did pretty good. Or did quite good, actually. Okay, installing. Okay. No, I haven't tested specific tune strips like that. Let's get some connectors here. I guess I should wire it up before I plug it in. You can always see over here where plus and ground goes, right? So 12 to 48 volts, plus goes here, ground goes there. Nope, need a smaller one. Okay, so that is correct. And then on the other side it's even more clear, because we have red for positive and black for negative. Oh wait, shouldn't plug those in while screwing on them. It's better to screw it while they're not plugged in. It's not a big problem. But now I don't remember the wiring on these. Oh, okay, yeah, okay, so they're bare wires, that's fine. I actually have a Wago on here, because I've been testing it at some point, to link it to another strip. So we'll try, you can't even see anything. We'll try one strip first, and then we'll add a second one. So we just take one of the positive channels on this guy. Each of these is individually fused with 5 amps. And then we're going to take one of the higher outputs, because the AN Penta Mini has 3 times 3 amp outputs and 2 times 5 amp outputs on the negative side. There. Hey, Andy. Okay, I'm not going to unwind this now. We'll see what happens. Well, and I'll unwind it a little bit, actually, because I want to show you the strip. Because this is a special strip I had constructed, but I never followed through. So this is a custom strip. I never followed through in getting it produced. Might at some point, might not. But, yeah. Getting custom strips produced is quite expensive, basically. But the nice thing about this strip is that it's a silicone housing, so it's weather tight. I believe it's officially IP67. Yeah, IP67. But it has a built-in diffuser layer. So let's give that a try. Let's keep the power supply. Let's put on the glasses again. There. Okay, so this is 48 volt into an AN Penta Mini, which is then connected to this LED strip. And when I hook it up, I think it'll do nothing, because WLED starts in orange when this is connected to one of the white channels. So we'll see. But maybe the AN Penta Mini will blow up because we're giving it 48 volts. It shouldn't, though. Let's go. Okay, nothing spectacular happened. Now let's take my phone and see if we see a WAP. We do see a WLED AP, so let's go there. Sign in. Now, by default, this is configured as RGB CCT. So if you look down here, it's PWM RGB CCT. We don't actually have to change that. We can just go back and then slide down the color bar, slide up the white bar, and I think it's connected. No, it's connected to the other channel, so this channel. And there you go. We now have a 48 volt PWM controlled LED strip. And since it's an AN Penta Mini, I can just do this on camera and it's no problem. So let's see it full blast. It's using, wow, 50 watts. That's perfect. But even if you dim this one down real low, let's see how low we can go. 1? No, 1 is too low. 9, okay. It's a cob LED strip inside. Let's see, which value is this? Yeah. There. It's a cob LED strip inside. When I darken it down like this, you can almost see it. You can see the copper pads right there and at various places. But the copper pads are very far apart. Stop focusing on this. The copper pads are very far apart. Because it's 48 volts. So that means the cutting length is also pretty long. But even at this low dim level and with the camera adjusted, you basically can't see a single LED. So it just lights up as a bar instead of instead of individual LEDs. Bright lights, just as the script said. And yeah, the AN Penta Mini is able to control that perfectly. Yeah, so I've played with maybe getting this made as a custom LED strip. As I said, I haven't followed up on that yet because it takes a lot of investment and time. Oh, we could actually do a CRI measurement. I don't know if I have my meter here. I should. Hold on. Yeah, here it is. So let's dim down the studio lights. There. Let's set it to, I don't know, 206. And, okay, let's boot the meter. Now this is a very rough measurement, but, you know. Let's take a measurement. Let's try one more. Yeah. Okay, so, okay, I need to fix this. So we're getting a CRI of 91.5, but this strip was never made to be a great CRI. Although CRI 90 is, you know, decent. It has an R9 of, I think, 45, which isn't great. But as I said, this is more meant for accent strips and things like that. But it has a CCT of 2644, so it's nice and warm and white, warm white. So let's see, CRI. Yeah, see, so it has an R9 of 45. So it's an okay CRI 90. It's definitely not 95, CRI 95 or better. Yeah, PWM, I don't think I can measure. Yeah, the meter doesn't have an idea. It says 100 hertz. That's just because the PWM on the AN Pentamania is too fast. So it has no idea what's going on. That's fine. Yeah, so it's a nice warm white. It's not a super great CRI, but it's also not bad either. It was mainly an experiment as a 48 volt strip with a nice diffusion layer. So let's turn that off. Now let's add a second strip and see if we can feed both from a single injection. Exactly, Rylas. That is exactly how this product... yeah, thanks, Don. Yeah, it's a professional one. It was quite expensive. That's actually how the idea of this strip got born. Is this not getting too warm? No. We had this garden room built in the garden, well, you know, attached to the house, and it came with a rail or a section in the metalwork for an LED strip, but it didn't come with the diffusers. I was like, oh, could you get me the diffusers? I'll give you like, I don't know, $50 or something, $100, I don't know, for the diffusers, because then I have the right diffusers and I can put my own LED strip in there. They said, no, we don't sell the diffusers on their own. We only sell the LED strip installation with our controller and power supply, and then you get the diffusers with that. But I said, okay, how much is that? $1,400. What? How much? It's 6 meters of LED strip. Yeah, that's $1,400. And what kind of LED strip are you going to use? And they actually sent me the PDF, and it was box standard CRI 80 crap LED strip. And they wanted $1,400. I said, it's not even worth $100. Can you just give me the diffusers? Yeah, we can give you the diffusers alone. You don't have to buy the power supply, and you don't have to buy the controller, and you don't have to buy the LED strip. That's $600. What? I'm not going to pay $600 for diffusers. It's 6 meters. I mean, what? What is even going on? So I got so pissed from that. I was like, okay, I don't want to do any power injections. I want a 6 or 7 meter run without power injections. I just want a nice warm white. And I don't know what kind of diffuser I need to put on there. So let's get a strip that basically has the diffuser built in. And then I don't have to care about any of that. So that's what I developed. And then I never released it. But, you know. Well, of course they didn't know, but I mean, $1,400 for 6 or 7 meters of LED strip installation. Come on, that's just stupid. Okay, let's turn it off. Let's fix the camera. No, the camera's fine. Let's turn on the lights again. There. And let's get a second one. And let's attach it and see if you run 48 volt with 10 watt per meter LED strip. Oh, this one also has a Wago on there. If you can actually run 2 in series. Yeah, that's a problem because the LED strip inside needs to be a smaller diameter, Aritis. So I looked into that, and that's currently not an option. So also the diffusion wouldn't be the same because a single color LED strip like this is constructed very differently than a multicolor LED strip like the Dig Cop. So it wouldn't work in the same way, right? So sadly that doesn't work that way. Okay, I need to connect this. There we go. Oh, the order doesn't really matter. AN Penti and AN Penta Mini is now out of the shot. I don't know. Let's do it. Oh, Philip's going. Oh, later, Philip. Thanks for hanging around. It does, Gary. I use a special JST JWPF connectors on the IP65 versions. So those are waterproof rated JST connectors. And we even did a live stream where we submerged it for like a minute or so and it was fine. So let's connect to... did I turn it on? Yes. Okay. WLED IP again. Disable color, enable this, enable that. Go. Yeah, okay. So, let's go full power. Oh, it doesn't scale linearly. And I have a Wago on here, so I can actually measure it. Is it at full power? Yeah. Okay, let's measure that. Okay. Okay, so from the 48 volt that's going in at the front, we only have 45.39 left at the end. Could be worse. I mean, if the percentage-wise, that's not a lot drop. So, and that is also at 100%. If we go, to 50%, you're likely not to see any drop at all. Now we could compare the front and the end for 10 meters. So that'd be interesting. Okay, let's leave it like that. So this is the front and the end, and well, you can't see it on camera. Yeah, so on camera that looks the same, but in real life it doesn't. Although, unless you're looking directly at it, I don't think it would matter too much. So let's turn some more knobs. Right, like this you can see that this one is slightly brighter than this one, right? So I can turn up the power. Yeah, you can see that this one is slightly brighter than that one. It's not a lot, but it is definitely brighter. But this is after 10 meters of strip, right? So, I mean, that is a long strip. Okay, now I need to get this back to the correct settings. Okay. But yeah, an AN Penta Mini, 10 meters of this strip, and then this power supply, well, we could do 20 meters of strip, but then you'd have to do power injection. You can do that from the same terminals if you want to. Or we could actually see what it does to the wattage. Let's turn this off. So, okay, okay, I need to turn it on again, damn it. Let's see if power injection helps. Come on. Okay, no color. We want full white, full power, full this. It's using 81 watts right now. 81. Okay? Let's turn it off. Now we can use one of the second positive outputs. Oh, we could actually see what happens if we use... No, that'd be bad. I don't know. We can use the second positive output, so we can screw it in there. There, but then we need to use the same negative output. And as long as you're not exceeding 5 amps for the AN Penta Mini, that is fine to combine like that. So we just put it in the same terminal. We could also use the same positive terminal, but it's just easier like that. Okay. Oh, that's fine. You can use some wires, that's no problem. As long as they have an appropriate diameter, that's fine. So we go here again. No color, whites, full power, full power. There. Okay, we had 81 before, I think. We have exactly 100.0 watts right now. So even on 48 volt, if you're doing 10 meters, we had, well, how much did we have before? 81. That's 19 watts difference, which means, you know, there's some losses that are being made up. Yeah, Don, there should only be one name. If you have 5 channels, red, green, blue, dual white, it is RGB CCT. RGB WW, RGB CW, that's all wrong. That is RGBW, so 4 channels, but then with warm white or cold white. And if anyone uses it for anything different, they shouldn't use it at all. They should just use RGBW. They're doing it wrong. So anyway. Hey, Ben Riss. This is a 48 volt power supply driving an AN Penta Mini, driving 10 meters of 48 volt warm white LED strip. Currently it's on WLED, but you can just as well run ESP Home on there. That's fine. Yeah, but yeah, so you can see power injection even with analog and 48 volt strip still makes a difference. Yeah, it's about 10% brighter, or basically it means that now this part is exactly as bright as this part and all the parts in between. So, oh wow, yeah, that's really blown out. Okay, I'll turn it down. There. A little bit more. There. It is a very nice 2700K. But yeah, this strip isn't available to buy anywhere. I haven't seen it available like on AliExpress or something like that, because it was made to custom specifications. I'm still debating or not decided if I'm going to release it or not. The problem is my whole enterprise isn't really set up to release LED strips, basically. Yeah, so. But this diffuser is pretty nice. Maybe at some point you'll see a project of me actually installing this. But that is why I got this power supply, which is, of course, cold as a rock right now. And you can, combine it with the A10 Mini like that. Whoa. And then have the LED strips attached. I believe these have 480 LEDs a meter inside. Yeah. 480 chips per meter. So yeah, I guess that was the secret for today, that I had this developed and never released it. I might still in the future, I don't know. I was kind of hoping someone else who is better suited to bringing out LED strips would have at this point, because 48 volt LED strip is nice. You can bridge longer gaps and things like that. But yeah. On AliExpress now you can find some 48 volt RGB CCT strips that are pretty good. Those are pretty good. But yeah, if you want nice diffusion like this, I haven't seen that being released yet. Ward, maybe I could partner with BTF or something like that. But then again, they could just release this themselves. They don't need me. So, yeah. So, yeah. Pretty cool. So let's get this back in the bags. How am I going to get this back on the spool? So, I mean, that's the problem with these things. If I invest a lot of money to release this, and then one of the big vendors says, oh, yeah, let's copy that, or make the same, or we were working on the same, or whatever the way it goes, I'm basically screwed, because I can never do it for the price they do it for. And then I'm left with, like, I don't know, $10,000, $20,000 investment that I'll never recoup. So, I mean, yeah, it's difficult, a difficult market in that sense. The margins are really, really low. I don't make a lot of margin on any of my products, but yeah, if I have to replace a strip, I basically have to sell 20 more to make up those costs. And yeah, if you do like 10,000 strips a month, that's fine. But as I said, my business or my enterprise isn't really designed for that, so. Oh. I am located in the Netherlands at the moment, and I have been all my life. Yes. If you don't believe me, check the beginning of the stream. There was some Dutch in there. It was horrible. Oh, no, wait. No, there wasn't Dutch in there. There were Dutch accents in there. It barely fits the bag. Don't do it. No. Once is enough. Don't worry. We agree Quindo would never do this again. Yeah, sorry. Don't worry, don't worry. Oh. These spindles are only just big enough. Your grandmother was Dutch. My grandfather was in the Liberation CDN forces. Nice. Cool. Okay, so let's see what the damage is. We had one missed frame due to rendering lag, and we had one skipped frame due to encoding lag, and we had 0 dropped frames from network lag. And I think the rendering and encoding lag was when I added the overlay for my multimeter. That's been known to happen before, so can't really fix that. But I think the new stream on using AV1 as encoding has been a great success. No, it's the same streaming PC, just upgraded with an RTX 5070 Ti, because it has dual NVENC encoders that do AV1 with new quality. And yeah, so far that's been pretty good. Live stream with LEDs and power supplies. No magic smoke, no blown up power supplies, but I think it was pretty fun. I showed you off one of my secret projects that I'm not sure I've ever shown that before. So, yeah, not all projects make it through in the end. It might at some point still, might not, I don't know. Yeah, AV1 is great. Yeah, it's going to save me a lot of... it's going to give you guys improved quality because I'm using the same bandwidth, just more quality. And it's going to save me a lot of storage. So, yeah. Okay, I'd like to leave it at that. I thank you all for watching. I already spilled the secret that next week, if everything goes right, the re-release of the Quinn LED Dig Cob will happen on Friday. So, now you know. And I hope to see you back in a future video, in the comments, in the live stream again, or on the Discord server. Okay, guys. Thanks for watching. Bye-bye.